Hey everyone, sorry I can't be with you today. Hope you're having a good day. Today we're going to talk about 4.1, which can do a little bit more of an extension of what we talked about yesterday as far as the radian values go, and just do a little bit of an intro into the trig functions. So I want to start off with a little warm up here of some of the values you had for homework last night, just to make sure that you guys are off to the right on the right track here. So we're going to start with this value right here, 140 degrees. So we think about our circle. 140 degrees is going to be just past 135. 135 would take us right here between 90 and 180. So 140 would be just a little bit past that, but not quite to 150, which is 30 degrees away from 180. So that is where we're going. Remember, this is a positive rotation, and positive rotations always take us in the counterclockwise direction. Negative rotations take us in the clockwise direction. I had someone ask me why that is yesterday and why we start at the point 10. Those are good questions. So I think the reason for that is because of the way the quadrants are numbered. So if you think about the quadrants, remember this up here in the upper right is quadrant 1, and then we have quadrant 2, then we have quadrant 3, and then quadrant 4. So if you think about it, it kind of makes sense that we would have a counterclockwise rotation be positive because we go through the quadrants in order then. Excuse me. So we have 140 degree rotation. We want to translate that to radians and then also to revolutions. So if we want to go to radians, remember it has something to do with pi and 180. So there's something with a pi and a 180. I'm going to take my 140. And since that's degrees, I want the degrees to cancel out. So I'm going to put the 180 on the bottom. So I have pi upstairs and I have 180 on the bottom. So we're going to reduce that. That looks like I could put the 140 on top because that's 140 over 1. So I can have 140 pi over 180. I can get rid of the zeros on the top and bottom just by dividing by 10. So I have 14 pi over 18. And I think we can divide those both by 2 to end up with 7 pi over 9. So 7 pi over 9 was the goal for that first one. Now for the approximate radians, that's where you can just grab your calculator. So I'm going to have you guys try that on your own. Remember, these solutions are all online on Moodle, so you can go and check to see if we got the same value. But you can just grab your calculator, hit 7 pi divided by 9, and that'll give you the approximate radians. Now for revolutions, we have two choices. We have our value both in radians and in degrees. For this example, I'm going to use the degree value. So remember the equation for degrees to revolutions, we just divide by 360. Because this should only be a part of a revolution. This isn't an entire revolution, it's only 140 degrees out of 360. And so if we reduce that, again, I can divide by 10 to get rid of the zeros on the top and bottom. So 14 over 36 looks like it reduces to 7 over 18. So it's 7/18ths of a revolution. That makes sense because it's less than half, right? Half of a revolution would be 9/18ths. We're only at 7. Cool. So let's take a look at another problem. Let's take a look at the one here where we have 5 pi over 11 radians. So this time I know the radians, I need the degrees, and I need the revolutions. Because again, for the approximate radians, I could just type that into my calculator. So to translate to degrees, remember, this time we're going to use our 180 and our pi again, but this time I want the radians to cancel out. So I'm going to do 5 pi over 11, multiply by 180 and divide by pi. And that's going to end up giving me degrees, because that's what I've got in the numerator. Looks like the pi's cancel. 5 times 180, well, 5 times 200 would be 1,000, and then I need to take away 100 because I have 20 away from 200 here, which means 20 times 5 is 100. So that altogether is 900 divided by 11 degrees. So that's the exact value of degrees. Let's think about where that would land us on the circle. So think about the circle here. So if it was 900 divided by 10, that would be 90. It's 900 divided by 11, so it's going to be just a little bit smaller than 90 degrees. So maybe like right about here. That would get us from 10 rotated up to here, just a little bit less than 90 degrees. Let's see how many revolutions that is. It should be just less than a quarter. So this time I'm going to use the radians. So I'm going to do 5 pi over 11. And the equation for radians to revolutions, I divide by 2 pi. Just like we divided by 360 up here, this time I'm saying what part of 2 pi have I completed? Now I can rewrite that as 1 over 2 pi multiplied by 5 pi over 11. The pi's will cancel out. Looks like that's going to be 5 over 22. It's equal to 5 over 22 revolutions. Now 5 out of 20 would be a quarter. So this is indeed a little bit less than a quarter because it's 5 out of 22. Let's do one now where we're given the revolutions. Let's start with 5/4 of a revolution. First, let's think about what that means. 5/4 is 1 1/4. So this is more than a full revolution. We've gone all the way around the circle. We've gone all the way around the circle, and then we've gone another quarter of a revolution. So it should land us right up here. And let's see what we get for our values. So to go from revolutions to degrees, I'm just going to do revolutions, 5/4, multiplied by 360. Now I'm going to do the division first. 360 divided by 4 is 90, so it's just 5 times 90. And 5 times 90 would be 450 degrees. Notice that's more than 360, because 360 would get me all the way around, and then another 90 gets me to the top of the circle. Really all that matters is that we end up at the top of the circle. You could go around 1,000 times, all I care about is where you end. So the radians, well, let's take the 5/4 now and find out, let's do with different degrees, because degrees to radians is the one that's a little bit trickier. So let's do 450 degrees. I'm going to multiply by pi and divide by 180 degrees because I want those degrees to cancel. The zeros will go away. So I have 45 pi over 18. Those are both divisible by 9, so I can divide top and bottom by 9. That's 5 pi over 2. Now we talked yesterday about the pi over 2's. That happens every 90 degrees. So that would be 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2 is 2 pi, and then 5 pi over 2 back to the top of the circle. And that's all there is to it. Cool. So I want to go through again how we were able to find our radian values yesterday. This is so important because in calculus all the time we see like we have to be able to get to pi over 3 on the circle very quickly. And so we have to know these radian values. So we divided it into 2 different parts. The first one we did was we divided the circle into 8 pieces. So I'm going to try to draw some straight lines here. So this has the circle divided into 8 pieces. They should be even if I had drawn a little bit better. This one's not quite in the right spot, but that's okay. So I've cut it into 8 pieces. So cutting the circle into 8 pieces, think about it in terms of degrees first. 360 degrees divided by 8 gives me a total of 45 degrees in each slice. So each slice is worth 45 degrees. So let's write all our degrees. So here's 0, 45. This would be 90. 135, 180, this would be 225, down at the bottom would be 270, over here would be at 315, and then all the way around would be at 360. Now let's think about that in terms of radians. We know all the way around the circle is 2 pi, because the circumference of the circle around the outside is 2 pi r. So if we take 2 pi, let's do this in a different color. So if we take 2 pi, and then divide it into 8 pieces. Each one of those pieces is worth pi over 4. So on the outside I'll do pi over 4. The next one would be 2 pi over 4, and I'm going to simplify it all at the end. So 1 pi over, this is 0 pi over 4, pi over 4, 2 pi over 4, this would be 3 pi over 4, this would be 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then all the way around is 8 pi over 4. Now, we can simplify all those. Let's do that in even a different color yet. About purple. So if we simplify these, pi over 4, I can't simplify anymore. 2 pi over 4 reduces to pi over 2. 3 pi over 4 I can't reduce. 4 pi over 4, that's just pi. 5 pi over 4 I can't reduce. 6 pi over 4 is 3 pi over 2. So I'm just reducing these fractions, divided both by 2. 7 pi over 4 I can't reduce. 8 pi over 4 is 2 pi. So you see, if you just count up by pi over 4s, it's very, very easy to find these values. You just have to reduce the fractions. So that's the 8 pi piece. Now let's see what happens if we divide the whole thing into 12 pieces. Go back to blue. So 12 pieces still is divisible by 4, so we have 4 pieces, and then we're going to do in thirds here. So each one of these pieces is going to be a 1/12 of the circle. So if I were to have the 45 lines in there as well, they would split in between each of these pieces in the middle of each quadrant. But right now all I want to focus on are those 12 pieces, and then we'll put it all together. So here we have the 12. Remember I told you if you can count to 12, I can teach you trig. So let's first think about degrees. So we have 360 divided by 12, which means each pi piece is worth 30 degrees. So we have 0, 30, 60, 90, put degrees on there. And then we have 120, and then we would have 150, 180, and then we would have 210, 240, 270 at the bottom, and then we have 300, 330, and 360 all the way around. Well, let's go over and change that to radians. So radians all the way around is 2 pi. So 2 pi over 12 means each one of those slices is worth pi over 6. So we start at 0 again. Now I'm just going to do the same thing we did over here. I'm just going to count up in pi over 6s. This is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6, and last but not least, 12 pi over 6. Now this one takes a little bit more effort to be able to reduce, but it's not so bad. So the pi over 6 I can't change. 2 pi over 6, that's pi over 3. 3 pi over 6 reduces to pi over 2. Whoop, 2, not 6. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6 I have to leave alone. 6 pi over 6, that's just pi. Notice that these line up, right? The top, bottom, left, and right on the circle are going to be the same on the 8 as on the 12. 7 pi over 6 I have to leave alone. 8 pi over 6 is 4 pi over 3. 9 pi over 6, those are both divisible by 3. That gives me 3 pi over 2. 10 pi over 6 is 5 pi over 3. 11 pi over 6 I leave alone, and then 12 pi over 6, of course, is 2 pi. So by doing this, by cutting the circle into pieces, we get all of the values on the unit circle that we need for radians that are important. Okay. Now, the system I use to be able to put this circle together is I first deal with the ones that are only on the 8 circle. So the ones that are only on the 8 circle are just those pi over 4s on the x's. So I just say, okay, I'm going to draw on those x's first. I'm going to use blue for that. So I just put in an x there. And I say, okay, those values are 1, 3, so pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So I put those in first because they're the only ones that don't work on the 12 circle. Everything else that's on here is on the 12. So I'm just going to put in those x values, 1, 3, 5, 7. All of the odd numbers, 1, 3, 5, 7, divided by 4. So 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. After I have those, then I put in the rest of my values using the 12 circle. So usually you'll have these coordinates written in. You won't have to draw them yourself, because when you draw them yourself, if you're like me, you can't draw very well. So here we go. Got all the rest of my values. So all of these red values, those are on the 12-piece circle. So what I'm going to do is just count up to 12, and I'm going to reduce in my head as I go. So this is 0 radians. Then I have 1 pi over 6, which I can't reduce. Then I have 2, 3, and 4 at the top. So 2 pi over 6 reduces to pi over 3. 3 pi over 6 reduces to pi over 2. 4 pi over 6 reduces to 2 pi over 3. So I went 1, 2, 3, 4. Now I have 5, 6, and 7. 5 I can't reduce, 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6. And then I have 8, 9, 10 on the bottom. 8 pi over 6, so I can reduce that though. That's 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. 11 pi over 6 I can't do anything about, and then 12 pi over 6 is 2 pi. So this is the system I use. First, the x values, 1, 3, 5, and 7 pi over 4. Then I just add these in. All you have to do is count to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So you might notice I kind of do that with a rhythm. I go around kind of with a rhythm. And this is what I call the cadence. Cadence is something that drums play in a marching band to keep the beat, but it's really, if you have a pattern for this, you can kind of use a little bit of rhythm, and it's easy to remember. So again, the first thing I do is I'm going to say, okay, those pi over 4 values need to be put in first. So I say I have 1, 3, 5, and 7 pi over 4. Now I go through all the 30s, and I actually do this with a rhythm. So I say, okay, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11, 12. So I stop every time I get to one of the pi over 4s. So this is actually what's going on in my head. And if you ever see me do this, I take my pen, I actually start it out to the right, and I say, okay, I'm going to start here, and then I move my pen as I go. I say 1, and I stop. Then I go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's the rhythm I use. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that gives me all the pi over 6s. So 1, 2, 3, 4. So 2 pi over 6, then I would have to say that reduces to pi over 3. Then 3 is 3 pi over 6, which is pi over 2. 4 is 2 pi over 3. So 1, 2, 3, 4, 5, 6, 7, 5 pi over 6, 6 pi over 6 is pi, 7 pi over 6. And at the bottom I have 8, 9, 10. 8 pi over 6 is 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. Then 11 pi over 6 I can't touch, and 12 pi over 6 is 2 pi. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And using that, I'm able to find any value on the circle. You tell me, hey, find 5 pi over 3. First thing I think is, okay, 5 pi over 3 is what pi over 6? It's 10 pi over 6. So then I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and right away I know exactly where you're talking about on the circle. It's not bad at all. So a few more tricks that you might find useful. There are all kinds of ways to find these radian values on the circle. I always count up using that cadence. But some people are looking for tricks, and there are so many tricks that you can use for using the unit circle. So if this is useful to you, great. It's kind of funny, but if it's not useful to you, you don't have to use it at all. So one thing that people notice is that when you look at the circle, there are a couple patterns. The first thing is that the pi over 4s are on the x, and we talked about that. This is the 1, 3, 5, and 7 pi over 4. 5 pi over 4 there. 5 pi over 4. And that would be 7 pi over 4. Now you also might notice that the pi over 6s, they kind of all happen at the same spots. So I call this the ninja. So the ninja happens at those narrow spots. So if you think about, like, you got a ninja, like, got his bandana on. So these are all the pi over 6s. So we have 1, this is 5 pi over 6, this is 7 pi over 6, and this is 11 pi over 6. So the pi over 6s happen at the ninja spots, at those kind of narrow x's. Okay? And then the hourglass has all the pi over 3s. This pi over 3, this is 2 pi over 3, 4 pi over 3, and 5 pi over 3. So you can kind of see, if you put all these together, you have all of the points except for the compass points. Those are the only ones that you're missing. And the compass points are easy. It's 0, pi over 2, pi, 3 pi over 2, and then 2 pi is the same place as 0. So easy to get these values by just taking a look and kind of mixing them together. And I think this is most useful when I see something like a pi over 6, like something like a 7 pi over 6, right away I know it's got to be one of these 4 points. And then it's just a matter of figuring out which one it is. So this might be useful, maybe not. So let's find these values on the circle. So 4 pi over 3. Like I said, my first, actually, if you want to give these a shot yourself, that might be useful. So if you want to pause the video and try to find where these are on the circle, kind of using whatever method you like, you can give that a shot, and then you can come back. We'll try these together. All right, welcome back. Let's see if we can figure these out. So 4 pi over 3, this is my method. I say, all right, 4 pi over 3, that is 8 pi over 6. Now I go through my cadence. This is 0 right here. So I go 1, 2, 3, 4, 5, 6, 7, 8. 8 pi over 6 is going to be right there. If we think about this being on the coordinate axis. Going to be down here. That's going to happen just before the bottom of the circle. That's where 8 pi over 6 lies. 3 pi over 2, I say, okay, how many pi over 6 is that? We'll have to multiply by 3. That's the same as 9 pi over 6. So here's 0. I go 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pi over 6 is right at the bottom of the circle. That's where we're going to be. Negative 3 pi over 4. All right, we got a negative value here. That means we just go down instead of up. The cadence still works. So 3 pi over 4, actually I don't need the cadence for this one at all because the pi over 4s are the x's. So we just do the same thing going backwards. So it should be negative 1 pi over 4. Then this right here is negative 3 pi over 4. Right there. At that spot on the circle. Kind of 45 degrees between 180 and 270. All that matters is we can get to that place. Doesn't matter if you go negative or positive. That's how you're going to get there. 11 pi over 6. Don't even have to change it like we did for the first two. So 11, I should go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 is going to happen right here before we get all the way around to 2 pi. So that's where 11 pi over 6 would get us right there. Negative 2 pi over 3, got another negative 1 here. So that, let's see, if we multiply by 2, that would be negative 4 pi over 6. So we're just going to count up to 4. 1, 2, 3, 4. And we go down because it was a negative rotation. So right there is our negative 2 pi over 3. 7 pi over 3. Ooh, that's a little different. In fact, I don't think we had that on our circle at all, right? There is no 7 pi over 3 on our hourglass. So what that means is we're just going to have to keep counting. I would count that as 14 pi over 6. So the cadence can keep going. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 would be right up here. So 14 would get us to this spot on the circle. We've gone around a full time, and then we've gone a little bit further. So that would be 7 pi over 3. Again, there are so many ways to get to the same spot on the circle. We just have to end up at the right spot, and that's really all there is to it. So why is all this important? Well, what we're going to be learning together on Friday is about the sine function and the cosine function. Sine and cosine functions have to do with the circle. All they are is if you're on the unit circle, so this point is 1, 0. If you have a certain angle, like let's say pi over 3, the cosine and sine of pi over 3, so this is pi over 3, are just the x and y coordinates there. Cosine is the x coordinate and the sine is the y coordinate. So the coordinates of this point right here on the circle, so this distance is 1 because the radius of the circle is 1. This distance up, or this point up here is going to be cosine of pi over 3, comma sine of pi over 3. Now we're going to get to how to figure out those exact values on the circle. The ones on the unit circle are super important. All those 16 important values on the circle. But today, all I want to say is, hey, if we do like, let's say like cosine of pi, that one isn't too bad. Because we know the radius of the circle is 1, so the point here is 1, 0. Pi gets us halfway around. So at this point right here, this is just saying, what is the x coordinate at that point? Well, think about it. The point there is negative 1, 0. So what is the cosine of pi? It's negative 1. Not so bad. We can do other values too. How about like the sine of pi over 2? Well, I have to be able to figure out where is pi over 2 on the circle. Pi over 2, that would be 3 pi over 6. So if we use our cadence, 1, 2, 3, right at the top of the circle. The coordinates there are 0, 1. Sine, we want the y coordinate. So sine of pi over 2 is 1. And that's really all there is to it. We'll learn more about the other values later, like cosine of 11 pi over 6, sine of like negative 5 pi over 4, stuff like that. We'll do that in section 4.4, but for now, just an understanding of, hey, the sine is the y-coordinate anywhere, cosine is the x-coordinate anywhere on the circle, and we take these of radian values of angles. We can do it with degrees too, like cosine of 270. Why don't you think about that for a second? What would the cosine of 270 be? So we're in degrees here. 270 degrees gets us to the bottom of the circle, down here. And the cosine is the x-coordinate. The coordinates there are 0, -1. So cosine of 270 would be 0, because it's not left or right at all. The x-coordinate there is 0. That's all I've got for you today. The homework today is going to be 4.1 in the blue packet, Lesson Master 4.1, so it's the next page after that big chart. A lot more converting between radians, degrees, revolutions, that kind of stuff. If you have any questions, be sure to check on Moodle. Mr. Murphy also has his videos up there if you're still looking for more. But solutions are all on Moodle, and you guys should be good. I hope you enjoy the Veterans Day Assembly today. Please remember to honor all veterans and to thank them for the service to our country. I love you guys. That's why I'm here. Have a great day.